This will be our topic. So let's try to calculate the deviation produced by Prism. So I'll be picking up a triangular prism, and its principal section is what I'll be showing it. A ray of light is incident here. This will be the normal. So after refraction, so this is the incident ray, refracted ray, this is the emergent ray. This is the angle of prism A. Now let's get into that one. So what are the principal sections? So I'm again showing a principal section of a triangular prism. This is what is this diagram? Principal section of a triangular prism. So this particular thing is an incident ray. It is monochromatic. What we discuss is monochromatic. Monochromatic. Monochromatic incident ray. Let the angle of incidence, let it be I1, and this is the normal N1, this is N2. Let this angle of incidence be I1. This is the refraction angle. So let this be medium A, this air. This is the glass, where refractiveness of prism, let it be mu. No. So the incident ray will make this the boundary, and this will become the normal. And the angle between normal and incident ray will be angle of incidence I1. This will be the refracting angle. As the ray moves from light to denser, so it should bend towards normal. So as the ray traverses a path, again it will encounter one more boundary. Now this will become the normal. This will be the normal for this particular surface. Some rough diagram I'm showing. So here now the ray is moving from denser to denser, should bend away from the normal. So let this angle of incidence, let me call a refracting angle. Though its angle of incidence, I'll use symbol R2, not I2 something. And let this emergent angle, let it be I2. So this is the refracting angle. The symbols is what I2 I'm using in this one. So what will happen to the ray now? The ray which I wanted to go, did it undergo any deviation? Yes, it is. This is the deviation. Delta is what I'll use for deviation. So in the absence of the prism, the ray would have just traversed this dotted line path. Now because of the presence, due to presence of prism, the ray is now, this is the emergent ray. This is the emergent ray. So the ray will take this particular path here. This is called a deviation. So it got deviated. Say I'm able to change the direction of path of the ray. I'm able to change the direction of path of the ray. Now, what did they say? A is called as angle of prism. This is the refracting faces. What we are seeing is the principal section here. What we are, I'm just interested to measure this deviation. So, what quantities usually I know? I know the deviation. I wanted to express this deviation in terms of angle of incidence I1, mu, and angle of prism. Let's try to get expression for this. Before this, we do have here a, I'll extend back this. E, so this is M, N, O, B. So this is the angle A. So this you call say some phi something. Let it be here. Huh? So we have cyclic quadrilateral. Cyclic quadrilateral AMBN. In cyclic quadrilateral, the sum of opposite angles should be equal to 180 degree. So therefore, A plus phi should be equal to 180 degree. So in the triangle, regular triangle, MBN, R1 plus R2 plus phi equal to 180 degrees. So equating these two, so this A should be equal to 180 minus phi. So there's R1 plus R2 equal to 180 minus phi. Substituting this is the equation 1, equation 2. So therefore from 192, R1 plus R2 equal to. There's a one equation you do remember, very important, almost at many places this will come. Huh? How these two angles are related to angle of prism given by this one. What is R1? R1 is the refracting angle, R2 is the incident angle at the second phase. So now after this, we'll apply the Snell's law at the first and the second phase. Applying the Snell's law. Sine I1 equal to mu sine R1. Similarly, mu sine R2 is equal to sine I2. This medium is here. The surrounding medium, let it be A. The refractive index of the material of the prism, let it be mu. So applying the Snell's law here, sine I1 is equal to mu sine R1. Mu sine R2 is equal to the sine I2. What we have to calculate? We have to calculate the net deviation delta. Call from Ravinder, Ready Street, Free Homes. We have to calculate the net deviation suffered by it. So the deviation suffered, the net deviation, this should be equal to deviation at M plus deviation at N. Deviation at M plus deviation at N. Deviation at M will be the ray wanted to traverse this particular path, but it got deviated. So I1 minus R1 should be the deviation. The deviation suffered by the ray at the first phase will be angle of incidence minus angle of refraction. Then this is the angle of incidence, this is the angle of refraction or angle of emergence, what you can say. So the ray wanted to traverse path like this here, but it got deviated. So what is the deviation at this point will be at the emergent phase, I2 minus R2. This is a deviation. So therefore this deviation is equal to I1 plus I2 minus R1 plus R2. So substituting this I1 plus I2 minus it. So this is the expression for deviation in terms of angle of incidence and emergent angle and this one. So this I2 will eliminate. I1 I'll be knowing at what angle the ray is incident on the prism. This I2 has to be eliminated here. So for that what happened? We will take help of some mathematics here. So first we will start with the mu sine R 2 is equal to sine I2. So therefore what is I2 is equal to sine inverse of mu sine R2. So this will become R2 will be A minus R1. Further expansion of this will be I2 equal to sine inverse of mu sine A cos R1 minus mu cos A sine R1. Or this will become sine inverse of mu sine A cos R1 will be root of 1 minus sine square R1. Sine R1 will be sine I1 by mu. So the expression for I2 will be sine inverse of sine square R1 will be okay, there is the expression for the deviation, sorry, the angle of incidence. So the net expression will be the deviation should be equal to now I1 plus I2 is this much. Let me adjust it properly. Okay, fine. So this will be minus of E. Okay, this is the expression for the deviation suffered by the incident ray due to the presence of the prism. Okay, I'm showing it completely now. Yeah. So what is delta? Delta you have to go to columns. So what is the delta? Delta is called as a deviation. So the deviation suffered by the ray of light is given by this particular. What is I1? I1 is the angle of incidence. N1, N2 are normal at the incident and the emergent phases. Now let's plot this deviation as a function of angle of incidence. Then we'll see that what conditions will arise. So we will take the deviation as a function of this angle. Hope everyone, this will be very simple. Just we took help of this equation, the deviation equal to I1 plus I2 minus A. This I2 is what emergent angle. This I2 is what should be replaced here, no? Because the deviation I should bring in terms of I1. So how to replace I2? First I'll mu sine R2 is equal to sine I2. Then I2 equals sine inverse of mu sine R2. So what is R2 is equal to A minus R1. I'm replacing this. Hope you'll get it. Then sine of A minus B formula, applying that. So I'll end up this formula. Finally, I'll get expression for deviation. So when I plot this deviation as a function of angle of incidence, the curve will be okay, this will be the deviation. So this will be the minimum deviation. There's some other colors we'll use. Not visible. Huh? I'll make them visible. You can see now. So this will be the maximum deviation, minimum deviation, and the deviation as a function of angle of incidence according to this particular equation. We have plotted deviation as a function of angle of incidence. On y-axis, deviation. On x-axis, there's an angle of incidence. Then how the curve will be? The curve will take shape like this. It's not a symmetric. You can see that it's not a symmetric curve. Are you looking this one? It's not a symmetric curve. So if one at one specific angle of incidence, the deviation will be minimum, huh? And there are two angles at which the deviation will be maximum. So we have to just calculate all this maximum deviation, expression for maximum deviation, minimum deviation, and at what angles the deviation will be maximum. That will be the next part of the discussion. So the complete description, I'll bring it. Yeah. So what all we have discussed here. So as what is I1? What is I1? I1 will be selected. This will be 0. So when it is along N1, it will be 0. As I keep on increase angle of incidence, then the deviation at what happen? It will start from one angle, maximum, then decreases. And at one specific angle of incidence will be minimum, then again it increases, again it will become maximum. So we have to calculate what are these angle of incidence at which deviation is maximum and at what angle the deviation will be minimum. Now you can ask questions, sir, what is use of this? The refractive index of material of any material is a very difficult quantity to measure, this mu. If I can measure this minimum deviation, I can calculate the mu of a prism, mu of metal of the prism. That's the main purpose of why we are studying these things. Later we'll go for applications. Okay, now, so what is our next target is like how to get expression for this minimum deviation. So we'll take help of this particular formula. I'll start from here. Okay, well, so next is expression for minimum deviation.